Problem 21 is asking us to substitute instead of square root of x t in the integral of 3 square root of x divided by x plus 1 dx. So part of this substitution is straightforward. Basically, where we see square root of x, we're going to replace square root of x with t. And in the denominator, of course, we see x plus 1. That has to be expressed in terms of t. Now, if square root of x equals t, then we can solve this equation for x by squaring both sides to get that x equals to t squared. Now that we can substitute instead of x into our formula for the integral. So we now have 3 instead of square root of xt over, and then denominator instead of xt squared plus 1. And next we have dx. This is a very important term and part of this integral. In fact, the reason every integral that you see ends with dx or dt or du or whatever the variable of integration is, d of that variable, is because this symbol dx, the differential of x, is present in that integral to make substitution in an integral easier. And so what we're going to do to rewrite this integral in terms of t, we will replace x with t squared under the differential sign. So next we're going to have times d of x, but x is the same as t squared, so I replace x with t squared. And that gives me d of t squared. Now, in order to evaluate this properly, let's remember what a differential of a function is. By definition, the differential of a function, let's say f of x or whatever the variable is, by definition that differential is equal to the derivative of the function multiplied by d of x, or times d of the variable that the function depends on. And so if we apply this to the differential of t squared, the differential of t squared will equal to the derivative of t squared multiplied by the differential of t. And the derivative of t squared is 2t. So we find that the differential of t squared equals to 2t dt. And that's what we need to put into our integral. So we have 3t, integral of 3t divided by t squared plus 1, multiplied by 2t dt. And we can now multiply 3t and 2t in the numerator to get the integral of 6t squared divided by t squared plus 1 dt. And this completes our substitution. We haven't actually calculated what the integral is, but we completed the substitution, which what this problem was asking for, and the integral that was originally written in terms of the variable x is now rewritten in terms of the variable t.